Hello everyone. The exam is tomorrow, Monday. Lighting. Yeah, that should work, right? Yeah. So tomorrow, Monday, the 29th is exam 2. This exam really covers everything that we've done as far as finding explicit solutions to, or even implicit solutions to differential equations, unlike the last one, which was all about finding sort of approximations to differential equations or initial value problems, or just getting a qualitative idea of how they work. So here, this one involves a bunch of calculus techniques, things like setting up the product rule, so you can use fundamental theorem of calculus that comes out of section 2.3 for the linear differential equations. And then separable differential equations can bring up anything out of calculus 2 as far as integration theory. I'm not going to make it too complicated, don't worry. I'm trying to test the concept of separable differential equations, not trying to test calculus 2. But you should know how to do things like integration by parts, basic U substitutions, that sort of thing. Don't worry about partial fraction decompositions. We're going to get plenty of practice on that in the next third of the class. Then other things that we're going to be talking about. So let's just break it down. So we have 5 concepts out of these 7 sections, I think. So we got 2.2, 2.3, we have 3.2, we have 4.2, 4.4, 4.3, and did we talk about 4.5? I can't remember. But the reality is that there's only 5 concepts. So separable differential equations. This one's basically that a differential equation can be written as a product of functions of the dependent and independent variables, respectively, and then you can divide by 1 and multiply by dt, and then you just integrate. That's it. That's all of section 2.2. The next one is linear differential equations, and that one is where we have to get an integrating factor. So integrating factors is basically you have to identify the p of x, and then you have to basically write this mu of x is equal to e to the integral of p of x dx, right? Multiply that through, and then that gives you a new thing to solve. Then after that we have what do we have? 3.2, which is actually a whole bunch of applications for section 2.3. So it's going to be a whole bunch of still finding the multiplying factor. The only thing that comes out of 3.2 is just figuring out how to write the input minus output differential equation. And once you've written it down, then you can just go and solve, and that's fairly straightforward. We have section 4.2, which introduces auxiliary equations, and 4.3, which also introduces auxiliary equations, but we have real and complex roots, respectively. And so really, that's just one concept. It really should have just been in one section. And then after that, it's the method of undetermined coefficients, and that's really all you got. The superposition principle just basically says that if you have a combination of forcing functions, just do method of undetermined coefficients twice and then recombine them. And then you might have to add on a homogeneous solution for a general solution. And that's it. I made a whole video on that chapter 4 section, so you can go and watch that if you want to get a good review. So then after that we have so it's just those 4 or 5 concepts that really come in here. 3.2 is just word problems that are basically section 2.3. There's going to be one problem from section 3.2, but it's a long each of those problems are pretty long, so I can't have more than one. So you have that. Section 2.2 and 2.3 have been available since before exam 1, so hopefully you guys are fairly comfortable with that by now. And so then what that leaves is just the chapter 4 material, which is all just whether or not you can factor quadratic polynomials and identify roots. And then the rest of it is just using a table to make guesses, and then trying to fit some coefficients. So yeah, that's exam 2. So don't stress about it too much. If you've been keeping up with what's been going on, then you should be fine. And if I can find time today, I'll try to do some recording for putting together a whole bunch of problems and exercises. In any case, hang in there, and yeah, good luck. Okay, so rather than just going through a whole bunch of homework problems, I figured I'll just pull a bunch of questions from the exams, rather than giving you my exams, which would send everybody into a panic because there's different topics covered in previous semesters I'm doing now. Changing to online has changed the format of the class, which means that some topics can be covered more effectively than others. So if I sent you the exams, you'd see questions about exact equations on exam 2, and you'd see using the method of variation of parameters, and etc. And then you just have a heart attack and you wouldn't make it to exam 2. And so I want everybody to survive, and so we'll just go ahead and talk about this here. Man, my babies again didn't sleep last night. Woke me up at like 3 o'clock in the morning. Anyway, I'm exhausted. I feel... Okay, let me stop complaining. And let's just start doing stuff. Okay, so here what you see is we want to find the general solution for this differential equation. So the differential equation they're giving us is y prime plus 2y is equal to x squared e to the minus 2x. This is a linear differential equation, and so what we're looking for here is an integrating factor. Here, p of x is just equal to 2, and so that means that mu of x is just going to be e to the integral of 2 dx, which is equal to e to the 2x. What's nice is when we multiply this through, we see that it's going to cancel this guy. So let's do that. So we have e to the 2x times y prime plus 2 e to the 2x times y is equal to x squared. Now, remember, this is supposed to be a product rule, and so this is the same as saying d by dx of e to the 2x times y is equal to x squared. All right, integrate both sides, and so we get e to the 2x times y is equal to x cubed over 3 plus c. And then we divide by e to the 2x to solve for y, so we get y of x is equal to x cubed over 3 times e to the minus 2x plus c times e to the minus 2x. And there you go. That's the solution. It's a general solution because c is allowed to vary. Okay, big thing a lot of people are probably going to forget is don't forget to add plus c, just like in calculus 2. And also, notice that this was plus 2y. Don't forget, if this was, say, minus 2y, that you'd want to have p of x equal to minus 2. Okay, let's go on to the next one. And you know what? I want a different color. Let's do blue. Okay, next problem. dy by dx equals 1 over y e to the x minus 2y. These are fun little problems here. This is sort of it doesn't look like it initially if you don't know your pre-calculus, but this is a separable differential equation. So this is actually equal to 1 over y times e to the minus 2y times e to the x. Right? So then that tells us that we have dy times y times e to the minus 2y is equal to dx e to the x times dx. Right? So integrate both sides. And so we're looking for the integral of y e to the minus 2y to y here, dy, and this should be equal to the integral of e to the x dx. And again, don't forget to add plus c when you get there. This quantity is just e to the x plus c, so that's no problem. This one is where integration by parts is going to come up. So we have integral of y times e to the minus 2y dy is equal to, say, u is equal to y, and dv is equal to e to the minus 2y dy. And so then we get du is equal to dy, and we get v is equal to e to the minus 2y divided by minus 2. Right, so we get u, which is y, times v, e to the minus 2y, and times minus 1/2. Minus the integral, so I'm just going to pull out the minus 1/2 here,
v du, and so e to the minus 2y, we already put in the minus 1/2 dy. And then we can just go ahead and integrate that. There's going to be minus 1/2 of y times e to the minus 2y plus 1/4. So put a minus sign of e to the minus 2y. And then, yeah, that would be that. So then we take this guy, move it over here. And so the answer we get is minus 1/2 y e to the minus 2y minus 1/4 e to the minus 2y is equal to e to the x plus c. All right, now we are asked to solve an initial value problem. And so we don't want just the plus c here. We want to solve it with y of 0 is equal to 1. So if I go ahead and plug in, this tells us that x is equal to 0 and y is equal to 1. And so we need to figure out what c is going to be. So then we figure out that, let's see, it's going to be minus 1/2 of e to the minus 2 minus 1/4 e to the minus 2 is equal to 1 plus c. And so then c is this. It is going to be minus 1/2 e to the minus 2 minus 1/4 e to the minus 2 minus 1 is equal to c. All right. And so then all together, let's put this in red, the solution to the initial value problem is given like this. It is minus 1/2 y e to the minus 2y minus 1/4 e to the minus 2y is equal to e to the x minus 1/2 e to the minus 2 minus 1/4 e to the minus 2 minus 1. And of course, we can simplify this a little bit by combining them. That will give us minus 3/4 e to the minus 2. But it's fine, leave it like this. You might see something slightly different if it's multiple choice, and just remember that you have to simplify. Okay, cool. So that's the solution to that problem. Remember, it was just a separable differential equation where we realized we can separate the exponential here like that, and then multiply both, do a sort of cross multiplication, just like good old algebra days. That left us with a trivial integral on the right and the more complicated one on the left. Oh, I had one mistake. Let's go ahead and catch that now. I had e to the x here. That should have been e to the minus x here, e to the minus x here. We left minus e to the minus x here. And so we would have had that. Not a whole bunch of changes, but it would change this to be minus 1 and this to be plus 1. So plus, minus, and minus. I moved that to the numerator without actually flipping the sign on e to the x. Don't make these small mistakes. That's all I can say. Okay. All right, let's go to the next one. Okay, so I want to find the solution to this initial value problem. So it looks like it's a second order linear differential equation with constant coefficients, and it's homogeneous because there's a 0 there. So this is going to be one of those auxiliary equation techniques. So the auxiliary equation for this is r squared plus 2r minus 3 is equal to 0. And we can go ahead and factor that pretty quick. It's going to give us r plus 3 times r minus 1 is equal to 0. So that tells us r is equal to minus 3 and plus 1. So that tells us that y1, for our two linearly independent solutions, we're going to get y1 is equal to e to the minus 3t, and y2 is equal to e to the t. And so our general solution is y of t is equal to c1 e to the minus 3t plus c2 e to the t. Okay, now they want us to solve this where we have y of 0 is equal to 0 and y prime of 0 is equal to negative 1. So let's go ahead and find y prime. So it's y prime of t is going to be equal to minus 3 c1 e to the minus 3t plus c2 e to the t. So y of 0 should be equal to 0, and that is going to be just c1 plus c2. and y prime of 0 should be equal to 1, and this is going to be minus 3 times c1 plus c2. Okay, so we can go ahead and quickly solve this. So this is going to give us, actually, if we take this equation and we subtract this equation, we get something that we can deal with. So we get 1 minus 0 is equal to, say, minus 3c1 plus c2 minus c1 plus c2. And so ultimately we get 1 is equal to minus 4c1 because c2's cancel. And so that tells us that c1 is equal to minus 1/4. And we see here that c1 is equal to negative c2. And so then it tells us that c2 is equal to plus 1/4. So the solution is then we get y of t is equal to minus 1/4 times e to the minus 3t, and then we get plus 1/4 e to the t, right? And there we go. All right, next problem. All right, so this one comes out of section 3.2, quite obviously. It's a word problem. The sheer number of words that we have here tells us that. So we're going to have one of these tanks, and so we know that it initially holds 200 liters of water, and initially has a 0.5% nitric acid solution. And flowing in, we have 6 liters per minute. And it's kept well stirred, and it flows out at 8 liters per minute. Okay, if the solution in the tank is 20%, the solution entering the tank is 20% nitric acid, determine the volume of the tank after t minutes. And then they want us to know, when will the percentage of nitric acid reach 10%? Okay. So, let's see. Alright, so for part A, we have dx dt is equal to our in rate, so it's 6 liters per minute times 20% nitric acid. So, okay, so we're going to have, let's see, 1/5 of that, 20%, is nitric acid. You just put 20% here if you want, or 0.2, and that'll be the same. All right, so now we're subtracting off 8 liters per minute. Okay. So so we have 8 liters per minute going out of whatever's in there. And so this is going to be, say, the volume divided by the volume of nitric acid divided by the total volume of the system. But the total volume system is actually changing. So this is going to be, starts at 200 liters. Then every minute we're adding 6 liters, but we're times t. And then we're subtracting 8 liters times t per minute. So ultimately we get 200 minus 2t here. And yeah, okay. So double checking. So this is unitless because the top and bottom are liters, and so it ends up being just a percentage, and that matches exactly what happened here. And otherwise, liters per minute, and we know that x is in liters and t is in minutes. So we have everything is well set up. So after this, it's a linear differential equation, and so we get dx by dt plus 8 over 200 minus 2t times x is equal to 6/5. Okay, that's not too bad. So our mu of x is equal to e to the integral of p of x dx, And p of x here is 8 over 200 minus 2t dt. All right, so that is going to give me e to the 8 times, it looks like it's going to be the natural log of 200 minus 2t divided by minus 2 by a chain rule. And so this is e to the natural log of 200 minus 2t, and this quantity ends up being, we have -4 out in front of it between the 8 and the minus 2, and so then that goes up into the exponent. So this altogether becomes 1 over 200 minus 2t to the 4th power. Okay, so we multiply both sides by that, and what do we get? So we get 1 over 200 minus 2t to the 4th power times dx dt plus 8 over 200 minus 2t to the 5th times x, and yep, this is equal to 6/5 times 1 over 200 minus 2t to the 4th. Okay, so this here, again, the whole point is to make it so that is mu. So our mu is 1 over 200 minus 2t to raise to the 4 times x, and then we're taking d by dt. And this we keep on the other side, 6/5, 1 over 200 minus 2t raised to the 4. So let's go ahead and do that. So we'll need to insert a new page here. Page book. And keep that there. Alright, so here we go. So now we integrate both sides. Integrating both sides, we get left hand side just canceled by the d by dt. So we get x divided by 200 minus 2t to raise to the 4. And on the right hand side, we get 6/5 times what is it going to be, 1 over -3 times 1 over 200 minus 2t to the 3rd. So adding 1 to the exponent, then we need to divide by -2 by the chain rule. All right, plus c. And yeah, let's see. So we have -3 and -2 is going to cancel 6, and so this can be rewritten as 1/5 times 1 over 200 minus 2t to the 3rd plus c. Now multiply both sides by the denominator on the left, and we get this. We get 200 minus 2t to the 4th power divided by 5. Oh, not to the 4th power. The cube on the bottom will cancel that. Right, and then we get plus c times 200 minus 2t raised to the 4th power. Okay, so now this was an initial value problem, and we were told we had initially 0.5% nitric acid with 200 liters. And so what is 200 times 0.5? Double check that. 0.5%, so 0.5%. That's basically going to be 200. Oh, this is off on the side. We have 0.5 over 100. That's going to be 200 times 5 divided by 1,000. And so then that's going to be 5 divided by 5, because 200 goes under 1,000 5 times, and that's just 1. Okay, so x of 0 should be 1. So x of 0 is equal to 1, and that is going to be 200 divided by 5 plus c times 200. Oops. Yeah, 200 to the 4th power. Looks pretty ugly. So then we get that c should be equal to 1 minus 200 divided by 5 divided by 200 to the 4th power. We can simplify that a little bit. So 5 over 5 is 1. So we get minus 195 divided by 5 times 200 to the 4th power. Okay. Not pretty, but that's what you get. Okay. So if you want, finally we get x of t is equal to 200 minus 2t divided by 5 plus minus 195 divided by 5 times 200 to the 4th power times 200 minus 2t to the 4th. Okay. Now what else do we need to do? When will the percentage of nitric acid reach 10%? So that's the question. Okay. Let's see. Can it ever reach 10%? So we're putting in 20% nitric acid. We have starts lower than 10%. So eventually it might be able to do it. The only thing we have to worry about is whether or not we're going to run out of water before then. And so then what we can do is we take x of t. So we're looking for what the percentage x of t. So we have 200 minus 2t. So that is the percentage is equal to 1/5 plus minus 195 divided by 5 times 200 to the 4th power. Then we get 200 minus 2t to the 3rd. And so it's a bit of a monster. Ordinarily on a written exam, I would just take, if you just put in 10% on this side and just solve. So basically the idea would be you're looking for when this is going to be, so this is a concentration equation. And so then you're looking for 1/10, that being 10%, is equal to 1/5 plus all that stuff. And then you'd solve for t, and that. But this would be too much to put on for an online exam. So the numbers will be a lot simpler. But that's basically what you have to do, is you have to solve for t here. Okay, so that gives you a general idea of 3.2. These are probably going to be the most complicated problems in the exam, but there's only going to be one of them. So don't worry too much. All right, so let's go back to these homogeneous equations. So this one, we're trying to find a general solution for y double prime plus 6y prime plus 9 is equal to 0. So we get r squared plus 6r plus 9 is equal to 0. It's going to give us r plus 3 squared is equal to 0. That tells us r is equal to minus 3. It's a repeated root. The general solution is c1 times e to minus 3t plus c2 times t e to minus 3t. And that is the general solution. So that's done. Here, put it on screen for a second so you can see it. But yeah, this is meant to be a gimme, 15% for this exam. So it was just a nice question. Find a particular solution to this one. So this is going to be a method of undetermined coefficients. So we get y double prime plus y is equal to 2 cosine of t. Generally speaking, you'd say, okay, method of undetermined coefficients tells me that maybe I should choose a sine of t plus b cosine of t times y. It's p. Then you'd take the two derivatives, so y is p double prime is actually going to be equal to minus a sine of t minus b cosine of t. You can work that out if you like. But we don't need y prime, so I don't need to bother with that. All right, add these together, so we get y sub p double prime plus y sub p, and then we need to figure out what the coefficients are. But if you add these together, you see you get a big fat 0. Why do you get that? Because cosine is actually a homogeneous solution to this differential equation. So how do you get around this? Well, the only way we know, you multiply by t. So y sub p equaling a times t sine of t plus b times t cosine of t, and this should be the better guess. All right, so let's go ahead and do it. So y sub p prime, this one's a little bit harder. So we're going to have a times, say, sine of t plus t cosine of t plus b, where we have cosine of t minus t sine of t, product rule. And yeah, so take next derivative, y sub p double prime is going to be equal to a times cosine of t here, and then we get plus cosine of t, then we get minus t sine of t, then we get plus b, and same sort of deal, minus sine of t, minus sine of t, minus t cosine of t. Okay, so now we're going to take y sub p double prime and add it to y sub p, and hopefully that'll leave us with some coefficients to play with. So let's see, we get a times cosine of t twice, so let's just put 2 cosine t, 2 cosine of t minus t sine of t, and then I get plus b, where I have minus 2 sine of t, and we get minus t cosine of t. Now we're going to add it to y sub p, so this was all y p double prime, and we get a times t sine of t, and we get plus b t cosine of t. All right, and so you see immediately we're going to have this term is canceling this term is canceling this term, and so what's left over is you get 2a cosine of t, and you get minus 2b sine of t. And now taking this guy and putting it on the right hand side, we see that this should be equal to 2 cosine of t plus 0 sine of t. Right, so that gives us equations. So on cosine we get 2a should be equal to 2, and on sine we get minus 2b should be equal to 0. So it tells us that b is equal to 0 and a is equal to 1. So our solution, let's do it in purple, pink, whatever you like, should be equal to where we put in a and b here. And so we get y sub p is equal to t sine of t. Right, and there you go. All right, let's take a look at another one. All right, so here they are telling us a particular solution to the differential equation. They want us to write down a general solution to the differential equation. So if you have a particular solution already, all you need to do is find the general solution. And so find homogeneous solutions to this differential equation. So we need to look at the differential equation y double prime minus y is equal to 0. And so that leaves us with the auxiliary equation r squared minus 1 is equal to 0, which tells us that we're looking at r is equal to plus or minus 1. So, so for part A, what we're left with is the solution that we're getting is the particular solution plus c1 times y1 plus c2 times y2, and this is the general solution y. And so then that tells us that y sub p is negative t. We were already given that. And then we're given plus c1 times e to the t plus c2 times e to the minus t. Right? Now we want to find the solution to the initial value problem. And so here we're given, oddly, we're given the second and first derivative initials values. So y prime is 0 and y double prime is 0. Something we can work with. I mean, it's easy to take derivatives of this. So, so then y prime should be equal to -1 plus c1 e to the t minus c2 e to the minus t, and y double prime is equal to 0 plus c1 e to the t plus c2 e to the minus t. All right, plug in 0. So t equals 0. It gives us this. We get on left-hand side, we're told that 0 is equal to -1 plus c1 minus c2. And for y double prime is also 0 on left-hand side. And so that gives me c1 plus c2. Okay. So again, if we just add these two equations, what we're going to get is we're going to get 0, we get -1, and then we get plus 2c1, and c2's cancel. So that tells us that c1 is equal to 1/2, and c2 is just negative c1. c2 is equal to negative c1, just from that equation. So that gives us -1/2. So the solution, let's put it in red, is y is equal to minus t plus 1/2 of e to the t minus 1/2 of e to the minus t. And there you go. All right, so that's not too bad. And yeah, that was it. So that's basically the course content. The trickiest problem here is really just this one. And if you can set this, if you can set up the equation, I mean, that's the bulk of the credit. This one, I was kind of careless when I chose this problem. And so ultimately, if anybody just set up the equation that would give me the answer, I would give them the points. But I definitely want to see that you can solve A. And that is the bulk of what I'm looking for on an exam. So yeah, so that's the idea, and hopefully that helped. Oh man, and now I really just want to go take a nap. Okay, so I'm going to throw this at the end of that video where I said I'm not sure if I'll get to it, and so I got to it. Yay. All right, bye.
Okay. So those are problems from exam 2. Hopefully this helped. Yeah, I think the scariest problem is going to be section 3.2. I'm so tired. Section 3.2 is probably going to be the hardest. But there's only going to be one problem on the exam from there. And as long as you set up the equation, that's going to be the bulk of the points. I want to see you be able to solve the solution, so then that's going to be the more or less the other half. And yeah. Big hint there, it's going to be a free response question. If I made it multiple choice, everybody would just fail. But yeah, but the rest of the exam should be fairly straightforward. Auxiliary equations are easy to do. There's an algorithm for finding a method of undetermined coefficients. Just memorize that tonight before the exam. And then we've had the separable differential equations and the linear differential equations floating around since before exam 1. So hopefully they're fairly obvious by now. So yeah. Anyway, I wish you luck, and yeah. All right, bye.